Yeah, hello everyone. As promised, here's the video that explains the sample output and also how you go about constructing it. So let's start. So as you know, this is the input that is given to you, right? So it's a square of some sort. The things in pink are the vertex numbers, vertex numbers, and the things in dark blue are the edge numbers, and the things in orange are the face numbers. So I think that should be clear by now. This is the convention that we're going to follow throughout the whole discussion here. So the question is, okay, this is the input and split edge number 2 and 3. So this is edge 2 and this is edge 3 as you can see. Right, let's look at the rules, yeah? So we have to essentially split the edge. By now you would know the process is we take the midpoints of this and then we construct a new edge. And then what? That's the question. Yeah, the big question is then what? There are so many ambiguities and so many confusions regarding what is to be done. How are we going to number them? So we have come up with a few rules and a certain convention. Now you could say, this convention is wrong. Perhaps you could rule it another way. Yes, that is true. There are many ways of doing this problem, but if you follow a set of rules, then you will get consistent output, and that's always a good thing, right? So the first rule is after splitting the edge, the new edge generated will have the index equal to 1 plus the previous greatest index. What does that mean? So as you can see, the edge indexes here, or indices, I guess, is 0, 1, 2, and 3, right? So the highest one here is 3 in the figure. So now this edge which you constructed from 2 and 3, this would get the index 4. Okay, so that's this part here. So that's settled. Now the second step is, as we call split 2 to 3, the next greatest vertex number will go to edge 2, and the one after that will go to edge 3. We will follow the edge from V2 to V3, take the twin edge back, and after forming the new half edge, we'll go in the clockwise direction to index the next edges formed due to the split. This is a mouthful. I can't lie. So maybe I can explain it with an example. So we split this edge to this edge, right? So this the representative vertex here is this, and the representative vertex here is this. Okay. Now what we do is they say that we name the edges. If we call split from x to y, we name we number the representative edge of x first, and then the representative edge of y. So in this case, the representative edge of x is 4 and the representative edge of y is 5. As you can see, there was a 0, 1, 2, 3. So the next ones in order are 4 and 5. Okay, so we named them. Now what do we do? Now how do we number the remaining edges? So what we do is you traverse from 4 to 5, and then you so when you're creating it, so you create an edge from 4 to 5, then traverse it, and then take the twin edge back. Take the twin edge back. So as you know, every edge has a twin that points in the opposite direction. It has the same face. It has the same vertices that it connects, and obviously it has a number as well. So you take the twin edge and you go to 4. Now we are at 4 and we have to go to 5. So here is where a lot of the controversy stemmed. Which direction do you go? There could be more than one way you go. So if you were to number this, we can go like 5, 0, 1, 2, 4, or we can go 4, 3, 5. What do we take? So the general overarching property of a DCEL is that the thing is clockwise. So in this case, we have to go from the representative edge of x to y. So remember, we call split of x comma y. So in this case, you have to go from 4 to 5, and there's only one way you can go from 4 to 5 in a clockwise order, and that is like this. So you go like this and like this. Now, while we are traversing this path, there could be one of two things. One is the edge already exists, or as in the edge already exists and it has a number between those two vertices, or the edge doesn't exist and we have to create it. So the idea is, if the edge doesn't exist, you create that edge or you renumber that edge if you have to, and or even if the edge exists and you have to renumber it in that case as well, you renumber it in order, sequential order. So we go from 4 to 3, then 3 to 5. So both of these edges need renumbering because obviously you split it. And so this becomes 5 and this becomes 6. The previous highest edge was 4, so it goes in that order. And now you have two other fragments of this edge from 2 to 3 remaining, that is 2 to 4, and that is 0 to 5. And this original whole thing was 2, and now you split it into 5 and something. So that something retains 2. Similarly, this 0 to 5 thing returns 3. Okay, clear? Now the next part is the new face will be generated by the split and will contain the new edge along with the remainders of the old edges passed in split. So this is about face convention. So how you're going to number the faces. So the original face was face 0 and the new edge is going to be face 1. Every edge split, every split function you call will produce a new edge. So that's a guarantee. And so like now you have to determine what this face will contain. So this face will contain basically everything that you have traversed. So in this case, it will be this part of the diagram. So that would be in this phase. And obviously the remaining phase, much like how you did for the edge renumbering, your remaining phase would have the same number. So this is the first question, and I think this should have solved some doubts. Just in case you need it, we will solve another one. So now let's see. This can be done a little quicker, I guess. So split edge 0 and edge 4. So edge 0 is here, and edge 4 is here. So obviously, so this was the whole of edge 0. Now we take the midpoint 6 and 7. Now you can see the previous highest vertex was 5, so this becomes 6 and this becomes 7 because this becomes your x and this becomes your y, from the previous convention. So you create an edge, you assign it the next highest number edge possible. So the previous highest number was 6, if you remember from this diagram. So this becomes 7. Okay, so those are the first two steps. Now you go from 6 to 7 and then come back. And now you have to go from 6, vertex number 6 to vertex number 7. And there's only one way you can do that clockwise, that is like this. So, okay. You traverse it now. Now your current highest number is 7. So this becomes an 8. And now see 1 to 2 is unaffected by this split, right? Because you split 0 and 4. So you won't need to change the number here. But you will have to change the phase. We'll come to that later. So we go 8 here, and then we go here on 1. We don't change this because it's not required. And we also don't change this because this isn't changed as well. Now we have to create another edge from vertex number 4 to vertex number 7. We do that, and we assign the next highest number possible, that is vertex number 9. So that is the first 3 steps done. Now the fourth step is about the new phase. So we, as you can see, we've already traversed this loop. So this essentially becomes the new phase. And yeah, so the previous highest phase index was 1. So now this becomes 2. I would encourage you to maybe draw these diagrams out as I explained it, that way you'll get more clarity. Anyway, so this was 0, this was always 0, this was 1, and now this becomes 2, the new phase, and the remainder will have 1. Okay, so that is the first question done, and I hope this brings you a lot more clarity about what this question is and how you should go about it. Now the second one. Now, so this is the second question. Okay, it's a completely different question. Maybe you can follow along again if you want to. So this is the same diagram as before, and now the question is to split 1 and 3. So as you can see, this is 1 and this is 3. So this would form our x representative and y representative. So we do that. Now the first step was, I believe, to make an edge from 4 to 5. So in this case, we number it 4 because the previous highest was 3, and this is x. So this becomes 4 and this becomes 5. Create an edge, and now take the twin edge back. And now you're at 4, and you have to go from 4 to 5. The only way you can do that in a clockwise manner is to go like this. So you do that. Now you might have noticed that the previous highest edge number was 4, and this is something that you should change the number of. So this becomes 5. This doesn't get affected, so this stays as 2, and this gets affected because this edge is split, and so this becomes 6, which is the next highest number possible, and you're done. Now your previous redundant edges will still stay. So this is 1 and this is 3. This whole thing was 1, so this still becomes 1, and now this still becomes 3, and this will stay 0, whatever. Now about the face, you've changed this portion of the diagram, so this portion becomes the new face. So this becomes 1. The previous highest number was 0, and that stays here. So those are the perhaps three examples I wanted to tell you. So I hope this was helpful, at least in some way. You can definitely go to the GitHub page where we have, I've uploaded this document, maybe without the annotations, and I also, one of the other TS has also uploaded the sample output that is expected. And so you can definitely go check it out, and I hope this does help out a bit. Obviously, you might have known the news that your assignment is postponed, so you definitely have a lot more time to work on it. So I would suggest you start right away. Don't wait for any other assignments and so on. And yeah, thank you.